Kia ora and welcome to the screencast for Workshop 4 for 297 101 Statistical Data Science, and we're looking at data wrangling this week. And data wrangling is essentially the process of taking some data and sort of bending it to your will, if you like, to answer questions about that data. And we're going to be using the dplyr library, which is part of the tidyverse, and the data for this week is going to come from New Zealand school roll data from primary and secondary schools in New Zealand in 2023, and you can follow that web URL there if you wish in order to find the data for yourself. So I've taken that data for you and mushed it around a little bit to get it into a form that we can use. So we're going to start by running this first code chunk, and we'll see that it'll load the tidyverse. It'll then pull in that data. It may take a little while because the data set's quite large. We've got 66,261 rows and 4 variables. And those variables are school, which features the name of the school, ethnic group, which features the ethnicity of the students, level, which is the year level of the students, which ranges from year 1 up, and then the number of students. So each row here represents the number of students of a given school, of a given ethnic group at a particular year level. Okay, so that's what the student column here represents. One thing to note is we've put message equals false up here in the header for this code block. So this is what's called a chunk option, code chunk option, and this is going to suppress some of the messages that come out of the tidyverse and out of the read CSV. Okay, so you don't have to worry too much about that. And so we'll start working through things. It does say to make sure we can knit this document successfully before we make changes. So let's do that now. That's just to make sure that any changes that we make are the cause of something breaking, right? So if we get down to the end and we try and knit our document and it doesn't work, then it's our fault, right? Rather than my fault. Okay, so that works. Excellent. So the dplyr library basically has a number of verbs or functions that form the core of the package, and there's only really 5 of them, plus a 6th that allows you to do processing on subgroups at once. And the 5 that we're going to look at are filter, arrange, select, mutate, and summarize. And then we'll be looking at group by. And each of those things basically serves a different purpose. And most of the data manipulation that we'll be doing uses sort of a chain or a sequence of one or more of those functions, one after the other, to answer a question. So we're going to start with filter, which is for selecting rows that satisfy one or more conditions. Okay. So for example, this code here, filter the role data. So role here is the name of our data frame, so we can see it up here. And so we're filtering the role data such that the ethnic group is Māori. Okay, so let's run that code and see what happens. We can use the we play button there. Then you can see that it returns fewer rows. So instead of 66,000 rows, we've now only got 16,800 or thereabouts. And you can see that all entries in the ethnic group column are now Māori, right? We've filtered out just the Māori information. Okay, so you can see that this here is a Boolean expression or a logical expression. It's something that returns true or false for each entry, right? Notice that we've used 2 equal signs for is equal to. A single equal sign is set it equal to, right? Now you do actually get a handy error if you accidentally mess it up, which I'm sure you will. I do it all the time, right? So if you accidentally put one equal sign and you try and run that code, then you'll see that we get an error. We detected a named input. That's because it's interpreting this as assignment. So we're assigning ethnic group the value Māori. This usually means that you've used equals instead of double equals. Did you mean, right? And of course we did. Okay. The other thing to note is that the word Māori here contains a macron, right? There's a wee line above the A, because so this is a long A, I think it is, in Te Reo. And so we need to know how do we get that on our keyboard? It depends on the computing system. So I recommend that you install the New Zealand Māori keyboard setup on your computer. So you can do that on Windows and on a Mac as well, and that will allow you more easily write macrons. And of course, because you're in New Zealand, that makes sense, right? Because a lot of words are te reo. How else might you do it? Well, how else I would go about it is I would just have a look at the roll data, right? So I would just type roll, okay, and I would look through and I go, well, okay, well, let's have a look through the ethnic group there. Let's just keep going down. There's one there, Māori. Let's highlight that, copy, paste. Right, now I've got it. I know that the text is correct, the spelling is correct, the characters are correct, because it's literally copied and pasted from the data, so I know that it will match. Okay, so that's the way to do that. Okay, another way to do it is to use count. Okay, so the count function takes the roll data and a column, and it just counts the unique instances in that row. So that's a useful way of just finding what's in this column. So what's in the ethnic group column that I can use, then it will give us the entries. And we see that there's 7 entries in the ethnic group column: Asian, European, International, Fee Paying, which is a bit odd. It's not really an ethnic group, is it? Mila, which I think stands for Middle East, Latin America, and African, I think. Then Māori, Other, and Pacific. And then the N here is how many rows there are of each one, right? So we've got 11,448 rows corresponding to Asian, and so on and so forth. Okay, so we could copy and paste the Māori from here. Okay. And of course, this doesn't actually apply. Doesn't only apply to Te Reo. There's plenty of other languages outside of English that use various other macrons. So that skill is quite important. Right, so what else? Let's have a look at some other examples of filter. So let's see what these functions are doing. Right, so this first one is filtering our roll data such that the ethnic group is Māori, right? That's what we did before. But we notice we've got fewer rows here, only 1,800 or thereabouts, because all of the rows also have to satisfy the second criteria, which is that the level is year 1. And if I scroll across, you can see that the level variable is always year 1 for all observations. So this is a logical and, if you like, right? The rows that are returned must satisfy ethnic group equals Māori and must also satisfy level as year 1. Sometimes you don't want an and, you want an or condition, and that's what the second line is doing. So the vertical bar there, which is above the enter key on your keyboard, that's an or operator. So this line here will return rows where the ethnic group is Māori or where the level is year 1. Right, so if we look down here, we've got rows where the ethnic group is Māori, and of course the year level does not have to be year 1, so we've got other year levels here. But all of the ones where the ethnic group is not Māori have to be year level 1 in order to satisfy that criteria. So that's how you do an OR. There's another couple of tricks. So a common technique when you have a grouping variable, such as level here, or ethnic group for that matter, is that you want to pull out 2 or more categories at once. So for example, my son is currently in year 2, but is in the junior section of the school, right? So if I wanted to look at the junior section of his school, I'd need to pull out year level 1 and year level 2 at the same time, right? So this is pulling out all the year level 1 and year level 2 students, right? So year 1 is 1 or 2. And because this is a sort of a common operation, then there's another way to do it, right? So you've got the in operator, so percent in percent, which is then followed by a character vector that's combining the two levels together, so year 1 and year 2. And the idea is that the second one, so both of these will produce the same answer, but the second one is easier to extend, right? If I wanted to extend this to year 3 and 4 as well, I would have to write, level equals year 3, and then level equals year 4, right? Whereas for this one, I just have to put year 3 and year 4, right? Done. So much less typing with this one than with this one. Okay. Less potential for making a typo. So here's some to try ourselves. So let's find all rows corresponding to Queen Elizabeth College students, which is a college here in Palmerston North in year 9. So we're going to take our roll data and we're going to filter it such that, well, we want Queen Elizabeth College, so that's going to be the name of the school. We want the school equal to Queen Elizabeth College. Now, I'm not going to try and answer this question in one go. Instead, I'm going to do it in bits, right? So let's just run that to make sure that we've got the right school. And yes, we have. Excellent. There's our Queen Elizabeth College. But we only want year 9 students. So now we can also add a restriction that the level has to be year 9. Okay. And so that then drops down to just our year 9 students. And we can see that in total we have 61 students at Queen Elizabeth College in year 9 last year. Okay. What about this next one? Find all rows where there are more than 100 year 9 Asian students. Right. Okay, so again, this is a filter, right? We're taking our roll data and we've got a couple of restrictions, right? We've got Asian students, so that's an ethnic group restriction. We've got year 9, that's a level restriction. And then we've got more than 100, which is a student number restriction, right? So there's going to be 3 different things here. So we're going to go ethnic group is Asian, right? So we'll just run that to make sure that that's okay. Yes, that looks fine. Our ethnic group is just Asian students, and we've reduced the size of the data set. That seems to be working. We need year 9. So there we go. We can go across and check that, sure enough, we've got Asian students in year 9. And we need the number of students bigger than 100. There we go. Okay. So there's only 22 rows left, and we can see that there's some categories that have large numbers of Asian students in year 9. Okay. So it's always useful to break down the code as you go and check each step, right? Because then if you get a problem, you can immediately correct it, and you're not trying to sort of debug some sort of more complicated thing later on. And what about this last one? So find all rows where the school name begins with the letter G. Well, there's a couple of ways to do this, as the hint specifies. It says you can use school greater than G for this. So let's see what that does. So you can see that, sure enough, we get schools that start with the letter G. But we've got 54,000 rows, which is a fair chunk of the original 66,000. And that, of course, is also including schools that start with the letter H or I or J and so on. Right, so we're going to need an additional restriction in that the school has to be less than the letter H. Right, and now we've got 2,000 schools, which seems about right to me. Okay, so that's one way to do it. The other way to do it is indicated by the hint. Using starts might be better. So let's have a look at perhaps the help for starts. So let's go filter roll, and then we'll go starts, and I'm just going to press F1 while my cursor is on starts, and it says detect the presence or absence of a match at the start or end. So starts and ends are special cases of detect that only match at the beginning or end of a string respectively. So we can see that it's we give it a string, which is in this case is going to be a column, and then we give it a pattern to match. Okay, so let's go down and have a look at the examples here. And we might just want to run these and see what happens, right? Let's copy and paste that example over. I'll just get rid of that code in the meantime. So here's a set of data with some fruits. So let's see what happens. So there's our fruit. Right, so type fruit so we can see what it is. There it is there. Now let's run starts on fruit with P. We can kind of get a hint that we probably are going to return pear and pineapple, aren't we? So it returns false for the first two because they don't start with P, and then returns true for the next two because they do. So this is a logical expression that is returning true if the fruit starts with P and false otherwise, which is exactly what we need in this case, right? We need the filter to return rows that start with the letter G, but don't start with any other letter, right? So we want starts school with the letter G. Let's reorder this maybe. Right. And sure enough, it gives us the same 2075 rows that the previous method did. Okay. Right, so that's filter. The next one we'll look at is arrange, and that's for sorting the rows or arranging the rows. And to do so, you've got to give it a column to sort by. Okay. And you can give it more than one. So, for example, in this code here, we're arranging the role data by ethnic group and then by level, right? So this is going to arrange by ethnic group, and then within ethnic group, our rows are arranged by level. Right? So you can see that within the ethnic group here, I've then got year level. Level is then arranged because, of course, ethnic group is going to repeat a bunch of the same things, right? There's only 7 different ethnic groups, so these are going to be arranged in 7 big chunks, and then within those chunks we're going to be sorting the level by year. What about the second one? So this is arranging the role. Think about what desk might mean. Let's run it and see what happens. Okay, so you can see here that it's arranged it by descending numbers of students. So 800 students is the highest number that we have in any row, and that corresponds to year 12 European students at Te Aho o Te Kurapunamu, which is the correspondence college. And you can see that that's actually high in many categories, right? And Te Puna Waipapa or Hagley College is also quite high. I think that's in Christchurch. So let's have a go ourselves, right? So arrange the roles by the number of students. Well, that's just the same as we had before, but just without the descending bit. Right, so we're going to get student numbers equal to 1. So this is just basically A1 Student Limited has 1 student of European ethnicity in year 10, right? And so on and so forth. Find all rows where the ethnicity is specific. Arranging them by decreasing number of students. Okay, so this is going to be a 2-step process, right? Because we've got a restriction on the rows that are returned, right? We only want rows where the ethnicity is specific. So we're going to do a 2-step thing. The first thing we're going to do is we're going to filter our role data where the ethnic group is specific. Okay, so there we go. That looks right. We've got about 10,000 rows, and the ethnic group is always specific, which is great. And then what I'm going to do is I'm going to save this into a data frame called Pacific. Now you'll see that when I ran this code, I don't get the data frame put out, and that's because I've got an assignment now, right? Not an expression, an assignment. I've taken the output from the filter and I've put it into the variable Pacific, and you can see that I have this new data frame up here, Pacific. Which of course is the Pacific data, right? Exactly what I would expect. But now that I've done that, I can then arrange them, right? So I can arrange the Pacific data by descending number of students. Right, so I can see that the school with the largest number of Pacific students at any particular year level is Kedgley Intermediate, which has 289 Pacific students at year 7. Right, so this is going to be technique 1. Use a temporary data frame to store the results of the filter. So technique 2, drop the temporary data frame, but everything is inside out. Right, so the idea here is that the Pacific here, the data frame that's now up here, I only need it to answer this question. I may not need it after that again, and so it's kind of superfluous, right? And it might sort of get in the way later, right? If I, imagine you were answering, 20 different questions about these data sets, and you use temporary data sets all the time, you might end up with 20 or 30 different data sets floating around up here, of which you have to provide names, that you have to remember what they are and so on, which, there's lots of scope for issues here. And so the other way to do it is to just notice that the Pacific's only been used to sort of jam into the arrange. So the other way to do it is to actually do everything all at once. Right, so I take my Pacific stuff and then I wrap it in an arrange. And that will, of course, give me the same rows. Okay. And now the problem with this is that everything is a bit inside out, right? If you think about it, the processes that are being done is we're first taking the raw data and filtering it, and then we're arranging it, right? And also this parameter here, desk students, applies to the outermost function, whereas the ethnic group equals Pacific applies to the innermost function, filter, right? So everything's kind of a little bit sort of inside out, okay? We'll look at a third technique a little bit later on, which sort of solves this inside-out problem. Which school has the highest number of international fee-paying students at year 13? Okay, so this again is a situation where we need to combine filter and arrange, right? Because we've got a restriction on which rows to return. We need international fee-paying students at year 13, right? So we need the level column to be equal to year 13, and we need the ethnic group column equal to international fee paying. Once we've done that, we then need to arrange by the number of students descending. So again, we might use a temporary, we might use a temporary data. Let's just start with our filter. So we want ethnic group equal to international fee paying. Right, we'll run that, check that it works. Yes. We also want the level to be year 13. Run that, check that works. Yes, that looks fine. And now we want to arrange it. So we could save it. Right, year 13 internationals. Okay, so now we've got our year 13 internationals, and then we could arrange it, right, by descending number of students. And we see that the UP International College of New Zealand has the most international students at year 13. There's 71 of them. Okay, technique 2, of course, is the inside out idea, right? So all we're going to do is we're going to take our arrange, and instead of that temporary data set, we're just going to take the filter and jam it into there. Right, so you can see that it gets pretty unwieldy, doesn't it? You end up with a lot of parameters, and it's hard to keep track. Even if you try and organize it, it can be hard to keep track of just what applies at what level and so on. Right, the code cleanup thing, whenever I press enter, sort of helps, right? I can see that these three things apply to the filter, and this one must apply to the arrange, but it's still, it's read inside out. And so there's a third technique, which is explained just a little bit below this, which is to use the pipe. Okay, and the idea is that you can write the same code right side round. So instead of inside out, you can do it outside in as follows. So you take your roll data, you then use a special pipe character, which is a vertical line and then a greater than symbol. You can insert this on your keyboard with, I think it's Control-Alt-M. No. Option-Alt-M maybe? Have a play around with your keyboard and see if you can figure out the exact thing to use. It's not Control-Shift-M on mine. Oh, there we go. So on mine it's Control-Shift-M. Let's see, it says down here. Let's have a look. Yeah, Control-Shift-M or Command-Shift-M on a Mac. We'll do it. We'll insert that character. And then we take our raw data and then we do the filter first. So that's the first thing. And the thing that we apply to the filter is we just have to specify the conditions. So we need international fee paying and level is year 13. And then we take the outcome from that, right? So the thing that we get from the filter, and we pipe that into the arrange function and run on the number of students. Right, that gives us the exact same answer, but it is way more readable, right? In that you say, take the roll data, do our filter on ethnic group and level, then arrange it, right? It's sort of self-documenting. It reads from left to right, which makes a lot of sense to us. And the bonus is that the parameters that are associated with each function are then directly inside the function, and we don't have this weird thing where the innermost parameters are sort of for the innermost function and so on. So what's actually happening here is this pipe thing is basically translating this code for us from this form into this form automatically. So it's done in the parser. If you want to know the technical details, you don't need to know the technical details, of course, but basically the sort of the main code loop, if you like, that interprets the R code is doing this translation on the fly. And what it does is it takes the thing on the left of the pipe and it inserts it as the first parameter in the function on the right. So in this case, it's taking the roll data and inserting it as the first function into the filter. Then this pipe here is taking the outcome from that filter and inserting it as the first parameter into the arrange, right? And so thus we get this set of code here. Now there are two different pipes. So if you've done Control-Shift-M on your computer, you may find that you get this symbol here. So that's a different pipe. It comes from a different package, but it does the same thing. Okay. So this one has been around for a while, for a lot longer. So this one that I'm using here is called the base pipe, and that's or the native pipe, and that's a lot newer. It's only a couple of years old, whereas this one here has been around for sort of 15 years or so. So you'll see this one in the wild a lot. You'll see it on Google and Stack Overflow and the various sites that you might find tidyverse code, so dplyr code in particular. And you can use it. There's nothing wrong with it. It does essentially the same thing, right? There are, of course, some technical differences, but you can ignore those. It will work essentially the same in 99% of cases. But it's probably preferable to use the same one that I'm using, just so that the code that you see or that you type is similar to the code that I type, right? Just so that there's a correspondence there. And you can do that by going into Tools, Global Options, and then Code. And you see that there's this option, Use Native Pipe Operator. Requires R 4.1 plus. That's no problem. It's been around for a few years now. Make sure that that's ticked. As long as that is ticked, then when you do your insert of the pipe, it will do the base pipe. Okay. The other thing to note is that the base pipe has to be on the end of the line, right? It's a bit like the plus in ggplot, right? The plus had to be on the end of the previous line. The same thing with the pipe. Okay, if you want to use multiple lines. You don't have to, you can type it all out in one line if you want, but it's a bit nicer, I think, to break it up and provide sort of a sequence, or a pipeline, if you will, of where the data kind of moves through the pipe. Okay, so that's what this is all talking about. Okay, so you might want to go back through some of the above exercises and redo them using the pipe instead. So for example, we looked at Pacific students, right? So we could take the role data and we could filter where the ethnic group is Pacific. And what did we ask about Pacific students and specifically? We said which one has the most, okay, easy. So we do a filter. Let's check that works. Yes, excellent. We've got our Pacific ethnic group there, and then arrange by descending number of students. Right, so there's the same answer, right? So Kedgley intermediate, same thing we got before. Okay, so all our code from now on will look like this. Okay. Right, so let's move on. We've got we've had two functions for selecting rows or reorganizing rows. We need to do the same thing for columns or variables. And the select is the workhorse for that. Okay, so the select function chooses which columns to retain or which columns to drop or which columns to rename or reorder and so on and so forth. Right, so let's run each of these and see what happens. So this first one is selecting the school column, the ethnic group column, and the students column. So is essentially dropping any other columns, right? So now I only have those three and I've dropped the level column. The second one is selecting everything except the school column. So the minus school is dropping the school column. So putting a minus before the name of the column drops it. And then in addition, we're renaming the students column to number. So that's that column there, which has been truncated for some silly reason in the output. Okay, maybe I'll just do num. Yeah, it's even truncated even more. Weird. Possibly to do with the size font I'm using, perhaps. What about this next one? Well, this next one, it's selecting the students column, so that will be the first column returned, and then the level column, that'll be the second, and then it's using the helper everything to give everything else. Okay, so this is useful for reordering columns, right? So here we've pulled the students column to the far left, the level column next, and then everything else. So it'll just put the other columns there. So the everything operator is intelligent enough to know that you've already picked two out and won't give you them again. So it won't repeat columns. There are a bunch of different helpers like everything. Okay, so this is quite handy when you need to just sort of grab 5 or 6 columns that might be sort of in the middle of the data, and you don't. It's sort of, you'd have to scroll across to see them. Obviously, with the display that is the data that are sort of pumped out at you defaults to showing you the left-hand side of the data. So it's useful sometimes to pull some columns over to the left so that you can more easily view them. Okay, so let's try these ones here. So rearrange the role data so that the students and level are first. Well, that's just that last code, isn't it? So we're going to select the students column, the level column, and then everything else. Easy. Here we go. Rename the school column to name, keeping all the other columns. Right, so take the role data. So we want the school column, but we want to rename it to name. Okay, so we need to do that, but we need all the other columns as well. Right, so at the moment it's only returned school, so we want everything else as well. So we could use everything to give us everything else. Is one way to do it. Okay, so the key thing with select is it will only return the columns that you ask for. It won't return anything else. So that's not too bad in this case because we're renaming the thing on the left. But if we were renaming, say, the level variable, how would we do that? Well, we'd try the same technique, right? So we'd say year is equal to level, and then everything else. That's going to work just fine. But now year's over on the left, right? So now we'd have to sort of rearrange everything somehow. Okay. The only other way to do it would be to actually specify everything, right? So this, right? So the other way would be to specify everything, right? So we could just, so we want the school, the ethnic group, the year, which we, the level variable, which we rename to level, and then students, right? So that's the way. So no order change, but way too much typing, right? So the other way to do this is with the rename function, right? Which is what this next one does. So because this is a sort of a really common task, we have rename. So you can look up the help for rename if you like. Okay, so rename, look at some examples. Here's some examples here. So rename in the iris data set, petal length equals petal.length, for example, right? So it's the same syntax as select. So we could go rename name equals school. Oops, school's not spelled correctly there. There we go. So now you can see that the school column has been renamed to name, and it's given us everything else. So rename by default always keeps the other columns. Okay, and so this is useful for when we rename the level variable, right? It also keeps the order, right? So we've renamed the level variable to year and kept the same level. Right, so rename is a happy helper for the case where we do actually need to rename things frequently. So this happens. I use so rename and select all the time. Actually, typically sort of at the start of a set of data analysis. So often the data that you get will come with some columns that you don't really need. Right, so they might be columns that just add some notes, or perhaps they're for another set of analyses that you're not interested in. So you just want to pull out a subset of the columns, which you can do with select. And perhaps also rename them so that they're a bit shorter or more succinct. Perhaps you want to get rid of spaces or whatever, things that just make it easier to type. Okay, so using select and rename is quite useful at the start of a set of data analyses. What about adding new columns? Well, in order to add a new column, you need some new data to populate it with, and the easiest way to do that is to use the existing data that you have. Okay, so let's have a look at these two examples. So we use mutate for that. So mutate creates a new column. If it's named, then which I recommend you always do. So put a name, and then you have a computation, right? So you can see that it's created a new column called proportion, and the proportion has been computed as the students. So it's taken the students column, and it's divided by the sum of the students. So what it's done is it's gone through and added up the sum of the students column, so that'll be all students at New Zealand secondary schools in 2023, which is probably about 800,000 or so. And so it's divided each of the values in students by that number. And so essentially this represents the proportion of all students that are of this ethnic group at this year level at this school. Right? So it's kind of a bit of a silly thing to do. It's not strongly meaningful because all the proportions are of course going to be very small because we know that the largest entry in any one row is 800, which is 0.1% or 0.001, right? So they're all really small numbers that are kind of meaningless. But nonetheless, it's and shows you how to do it, right? We'll look at some slightly more interesting examples next week. So what about the second one? So this second one is taking our role data and creating a new column called level. Now, of course, we already have a column called level, and so this will be overwriting the existing column, and it's doing so with this complicated looking expression here. And so we can kind of break this down by perhaps doing it in bits, right? So let's have a look and see what this is doing. So let's try just to see what the substring bit's doing. So let's take the bit from inside here and see what that's doing. All right, so we've got this new variable try1, which is this outcome from the substring on level. So I think you can see that what it's doing is it's basically operating on the level, on the entries in the level column, and it's taking everything from the 6th character onwards. So it's dropping the first 5 characters. So we're dropping the year and the space, which is the first 5, and starting at the 6th, which is the number, the numeric bit. Okay, and then we're basically doing, right, we're then converting that to a number, right? So if we have a look at try 2, that's the same, that's the number in try 1, treated as a number. So the purpose here is to convert the level variable from a character string to a number. And the reason we want to do this is that the level string at the moment will sort incorrectly because it's a character string. So if you sort this column, year 1 will be first, but after all the year 1s, you'll have year 10. Then year 11, then year 12, and year 13, and so on. And after you've done the teens, if you like, you'll then get year 2. And if you had year 20, then that would come next, and so on, right? So it's sorting alphabetically, not numerically. So we're converting the thing to numeric in order that we can then use that variable as a number. So let's run this code here. Right, so this is creating a new data set called clean. So you can see I've got my clean up here, which has 66,261 observations on 4 variables, the same. But now when I look at the clean data set, you can see that the level is now just numbers. Okay, so that's going to now sort as numbers. So, you know, the order will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, right? Exactly as you would expect. All right, so. Okay, so we're going to use the cleaned version of the dataset from now on. Okay, so using the clean dataset, create a new column combining ethnic group and level with paste. Right. So we're going to take our clean dataset and we're going to create a new variable. It doesn't say what to name it, but because we're combining 2 variables, let's say eth level, maybe. And that's going to be paste. Right, we could maybe look at the help for paste. Right, concatenate vectors after converting to character. Okay, let's have a look. Do we have some examples? Okay. So you can see that you can just basically feed it multiple things and then a separator and it'll put them together. At least that's my interpretation of that. Let's just play around maybe. So let's take the ethnic group and the level and paste them together and see what happens. Right, this is exactly what we might expect, right? In that it has just taken the entry in the ethnic group and the entry in the level and smushed them together with a space. So separates with a space. Right, we can specify the separator if we want to. So you can see here in this help here, we've got a sep. Let's do that, see what happens. Okay, so that separates now with a comma, then a space, right? So you can do other things. Right. Okay, so that's one such mutate. Let's do another one. Redo it so that the original 2 columns are removed. So So we want to create the new column, which is the paste of the two existing ones, and then we want to drop those two. So we can use select to drop them. So we'll just have another pipe and then use select to drop the ethnic group and the level. So there we go. Okay. Number 3, create a new variable age with the typical age of students in each year level. Okay, so what we want to do is we want to take the current year level and we want to add 4 to it, don't we, in order to get their age, right? So kids that are, or at least their starting age, I suppose. Kids that are in year 1 typically start school when they're 5. They'll become 6. They'll have a birthday during the year, and then sort of within year 1 they'll turn to 6, and then they'll start year 2 when they're 6. All right. So we need to add 4. Right, and so there is the age group there. Okay. So that's one way to do that one. What about this next one? Well, this one is asking us to investigate the unite function. So we could look at the help for unite. Unite multiple columns into one by pasting strings together. Okay, let's have a look at the example. So let's just copy and paste this and see what happens. Notice that this is using the old pipe. It's interesting, isn't it? Let's run this code and see what happens. So this is creating some data, right? So we've got we've got some X's and some Y's, and then we're uniting into a new variable Z, X and Y. Okay, so it's basically just grabbing these two things and pasting them together with an underscore, isn't it? Okay, so apply to our case. So we want to take our clean data and we want to unite to a new column called, what are we going to call it? Eth level. And we're going to use the ethnic group and level. And there we go, done. So we can change the separator. That's done with sep. Right, so we could go sep equals slash, right, if we wanted, or whatever, right? You can use a space, whatever you like. So you can see that this is combined those two columns together. It's removed the old ones. You can control that with the remove argument, remove input columns from the output data frame. It's also kept everything in the same order, which is quite nice. Okay, so we'll look a little bit more at uniting variables when we look at tidying data in week 6. The opposite to unite is separate. We take one variable that might contain 2 pieces of information and separate it out into the individuals. So you notice that this data format, we haven't lost any information here, but this is harder to use, right? Because if, for example, we wanted to restrict the data set down to European, so all the rows with European, we can't just say equals European, because European has this extra stuff tacked on, right? So we'd have to use some sort of a substring thing or a string detection thing or something to do that filtering. And the same with the level, right? If we wanted to pick out everyone with level 10, then we're going to have to go through and find all the 10s, which is going to be a more complicated task. Okay. But there's some cases where this actually makes sense. So some examples might be, so sometimes when you're constructing a table, you want you want rows to represent sort of combinations of two variables. So you need to sort of paste them together to make a sensible row labels, for example. Other examples are things that are by default compound. So for example, dates. So you may have a year column, a month column, and a day column, and you'll want a date column. So you need to combine those together to form a date column. And sometimes you're given a date and you want to split it up into year, month, and day, right? So you want to separate things. So you often go back and forth between these two formats. So the last of the main 5 functions that dplyr has is summarize. So we've looked at filter for choosing which rows to retain. We've looked at a range for ordering the rows. We've looked at select for picking out columns. We've looked at mutate for creating a new column. And now we're looking at summarize. So summarize takes all of the rows you have and drops it down to just one row, where the summary is computed from all of the rows. Okay, so let's have a look at these 2 examples here. So this first one is taking our clean data and summarizing and just giving us the number of rows. So the n function is shortcut for number of rows, right? So we've got 66,261 rows. So this isn't strongly useful. What about this next one? So this next one, so useful for counting. Okay, what about this next one? Well, this takes, again, our clean data, summarizes and computes the total at the sum of the students. Now that's something that's useful to us, right? Because it's the number of students in total, right? So we've got 831,038 students at New Zealand schools in 2023. The average, this is slightly less useful, is just going to be the total divided by the number of rows, right? So this is just the number of students per row on average. So on average, each row has 12.5 students. So that's like, on average, the number of students of each ethnic group at each year level across schools is 12.5. Now that's not very useful because, of course, different schools have different numbers of kids, right? So the average probably isn't strongly useful in this case. But nonetheless, we can compute it in this way. Obviously, we could use the mean as well, right? So we could do average 2 would just be the mean of students. That'll give us the same result, won't it? Because that's what the average is, right? The average is just the total, the sum of those numbers divided by how many there are. So the interesting thing about this computation here is I've used something that I've computed in the same line of code, right? So this is computed in order. It computes the total first, then it computes the average using the total, and so on, right? Which is quite handy to remember that it can do that. Okay, so let's do some examples. Find the largest maximum number of students in each row. So we could do this with a summarize, right? So we could go the maximum, or max students, if you like, is the max of the students column, right? So you remember we've got max and min for doing the maximum and the minimum. Okay, so the maximum number of students in any row is 800. Now we saw that also with a range, didn't we? So if we arrange by descending number of students, then we can get that same answer of 800. But in fact, we have more context here because we actually know that in the entire row, right? So we know that maximum occurs in a particular row. So we know it's the correspondence college. And we know that it's year 12 European students, right? So this. So it gives the entire row and other rows which we don't actually want, right? There's also, so there's another one, which is slice max. So order by is students. I think you just type students, I think. And then you just have to say how many you want. Okay, so this gives just that one row. And slice max n equals 2 would give you the top 2 rows and so on. There's slice min as well. Okay, there's a bunch of helpers like this for doing sort of tasks that tend to be repeated. So it's often a thing where you just want to find the top 5 or whatever, right? The top 10 of this thing. and you can do it with slice max, or the bottom 10 with slice min. What about the median number of students in a row? Then we can just use the median function. Right. So again, this isn't a strongly useful thing. So this just is the median entry, if you like, for that students column is 5. So that's, if you like, the middle number of students in each row, which again isn't strongly useful. This is the median number of students of each ethnic group and year level at a school. What about the lowest and highest year levels in the data? So this is slightly more interesting. So again, we could summarize and we could say that the lowest would be the minimum and the highest would be the maximum. Okay, so the interesting thing here is that it ranges from year 1 up to year 15, which you might not expect. Most schools, of course, only go to year 13. There's a subset of schools that go that have a year 14 and a year 15 as well as year 13. Okay, and then this next one, find the number of Māori students in year 9, is starting to get to useful questions. Okay, so how can we do this? Well, we want the number of Māori students in year 9, so that's a filter, isn't it? Right, we're restricting the number of rows. Right, so the first step is going to be filtering. So we want ethnic group equal to Māori. Now, of course, I need my macron, don't I? So let's very quickly copy and paste that with a count. I could get it from further up in the file as well, couldn't I? There it is there. All right, so first of all, Māori students. I also want year level 9. So level is 9. Let's check that. That looks to be working. So this is Māori students. Let's get the macron right. In year 9. Okay, so now that's all the rows that I need, and now I need to count them. Right, so I could do a summarize. So I just need to add up all these numbers here, right? And there we've got 17,879. So okay, and I'm done. Now the real power of dplyr comes from being able to do all of the above functions, so our filtering, our arranging, our selecting, our mutating, and our summarizing especially, per subgroup in the data simultaneously. So the group by operation allows everything else to operate per group. Okay, so let's have a look and see what happens. We're going to start with our original data clean. You can see it, I have 66,261 rows. And then let's see what happens when I add group by. So now, this is original data. This is adding the grouping. Right, when I run that, then I get the same data returned, right? I still have my 66,261 rows over 4 variables, but now I have this extra sort of tag, if you like, that says actually this data set has all this data, but the data are grouped by school, and there's 2,524 schools. And so that means that when I do other tasks, such as the summarize, instead of the summarize operating over all rows at once, it will operate over all of the rows in each group at once. So instead of returning just one row overall, it will return one row per group. So in this case, one row per school. Right, so this is the total number of students, because I've done the sum, in each school. Right, so I only have 2,524 rows, that's one row per school, and this is then is the number of students in each school. Okay, so total number of students in each school. Okay, and this is really where the power comes in. It enables us to do computations by subgroup simultaneously. And often, computations by subgroup makes sense, like in this case here, right, for getting totals. So let's have a look at these last three. So how many students of each ethnicity are there? Well, we're going to need to summarize across the ethnicities. So the first thing we're going to do is we're going to group by ethnicity. Right, I'm going to run that to make sure that it works. No, it doesn't. Oh, I made a mistake. Excellent. It's ethnic group, isn't it? There we go. So you can see that I've got my grouping by ethnic group. There's 7 of them. And then I'm going to summarize where the total number of students is just add up the students column. And there we go, right? So I've got 206,000 Māori students, 6,228 international fee paying, and so on. Okay. What about this next one? Which school has the most students in year 13? So now we're starting to answer some more sort of complicated questions, aren't we? Which school has the most students in year 13? So to do this, I noticed that I've got a restriction, right? I've only got year 13 students. So the first thing I could do is I could start by filtering the data down to year 13. Right? So let's check that. So I've just got year 13. And then I need to know the school that has the most students. So I need to be able to summarize this across all schools, right? And then I need to group by. So I need to group by school. Right, so this is going to be the same data grouped by school. So there it is there with the school group. So I've got 549. Notice I've got fewer schools here because, of course, I've only got secondary schools now. I've only got schools that have a year 13 class. Okay, so obviously I wouldn't have any primary schools here because they only go up to year 6. Or intermediates that go to year 8, for example, right? And so now I'm going to summarize by adding up the number of students. So there we go there. And finally, I need to know the one that has the most. So I need to arrange. By my new variable total there. So there we go there, and you can see that the school with the largest is Te Ahu o Te Kurapunamu, which of course is the correspondence college. Okay, so we could also use a slice here. Now order here is important, right? I did the filter first so that my group by and summarize made sense, right? I wouldn't want to do the group by and summarize first because if I did that, I'd lose the year level, right? If I grouped by school and summarized the total number of students, then I'd get the total number of students across each school regardless of year level. So I would lose the information about year 13. So to do it in a different order, I'd have to do it a different way, basically. Okay, so an alternate, more painful, I think, way would be to do the filtering last. right? So you could go clean and you'd need to group by school and level, right? 2 groups. So when we do this, I now get 18,661 different groups, which is the combination of school and level. And then I could add up the number of students. Right, and so now I've got a total number of students at each school for each level. Okay, so essentially what I've done here is I've summed over the ethnic groups, right? Because the only thing that I haven't grouped by was ethnic group. And so now I've lost my ethnicity information just by bunging everyone in together, right? So now I've still got multiple rows per school, but now I could do my filter, right? And just get my year 13. Okay, so there's my year level 13 numbers, and then I could again, maybe I could do a slice max. So we want to go by, what's it called, total, n equals 1. Now that didn't work because my data are still grouped. So when I did the slice max, it gave me 1 row per group. And I've already got 1 row per group anyway, so I'd need to ungroup it first. Okay, so we'll look into this a bit more next week. But the idea here is that, so I get the same answer, obviously, which is good. But this is a much more complicated way of doing it, right? Just because I chose to do the filtering last. It's also less efficient, right? If you think about the number of computations that need to be done, in this one, because I've filtered out only year 13, I've reduced the size of the data set right at the start. So now from then on, it's got fewer observations that it needs to look at for each of the subsequent steps, so it'll be faster to compute. Whereas in this one, I've done the filter sort of towards the end, and so it's retained a whole bunch of information all the way up till then. So we've computed, for example, the number of students at year 1 for each school, which we don't need to answer the question. Now, of course, computers are fast. It doesn't actually matter. I doubt you'll be able to notice the difference between each of these runs. It also gets more complicated because we need to ungroup. So what happens is that when you group by 2 variables here and then do a summarize, is it automatically ungroups by the innermost grouping variable. So in this case, it's going to be from level, and in this one, it'll be from school. So after doing the summarize thing here, there'll be no groups left because you've got rid of the grouping by school. After you do the summarize here, you'll still have it grouped by school. And that's because often when you do multi-layered grouping, you're wanting to do multiple multi-level summaries. So you might want the number of students per level as well as the total number of students per school. So you might want it to still be grouped by school after you compute that inner sum, right? The number of students of each level within each school. And so it hasn't ungrouped. And because of that, any other operation is done per group, and our slice max is basically arranging it per group and then doing a filter to restrict the number of rows that are returned. And that'll then be done per group, okay? Which isn't what we want, right? We want to ignore the grouping when we do the slice max. So thus the ungroup. Now, a plain arrange would have worked here, right? Because arrange, if you arrange within group and then sort by the group, that's the same as arranging all of the data at once, even if it's ungrouped. Okay, so that doesn't matter so much. Okay, we'll look into this in a little bit more detail next week. So the last thing is produce a graph of the total number of students by year level. Okay, so we're going to take our clean data and we're going to compute the total number of students by year level. So we're going to have to group by year level. And then compute the total number of students. Right, so that's the data that we want. Okay, so we have each year level, we have the total. And now we just have to chart it, right? So we want a graph. It suggests using a column chart, right? So these are these are counts, aren't they? So it makes sense to use a bar chart of some description. We already have the height of the bar, so that's a column chart, right? So now we're just going to pipe it into ggplot, recognizing that the first parameter to ggplot is the data set that we want to plot, right? So the data set that we want to plot is the outcome from that data wrangling. And then we switch to plus. We've always got to remember to switch to plus for ggplot. And then we can switch to setting up a column chart. So the X is going to be our level, the Y is going to be taken from our total, and we have our chart. Okay, we might want to add a label, number of students of each year level, perhaps a subtitle. There we go. Okay. So notice it does go up to year 15, but there's obviously very few year 14 and year 15 students. Here, this tailing off is as folk leave school before year 13. So we've got a bunch of school leavers at year 12. They leave at the end of year 11 and then don't go into year 12, and then a bunch more don't go into year 13. There's an interesting spike at year 7. I believe this is where folk are recategorized as they move into intermediate. So year 6, so this is primary education, and then this is sort of intermediate, and you get some weird sort of double counting thing happening here. I think that's what it's from. And there we go. So that's the idea with data wrangling. So there's 5 fundamental things. You've got your filter, your arrange, your select, your mutate, your summarize. And the real power comes from combining those with group by. Okay? And for any particular question, the task is really thinking about so what do I need to do to the data? So how do I get from the data that I've got, so all of the rows, to the thing that would help me answer my question? What are the steps involved? And sometimes you may just need to sort of write down in English or your language of choice the steps that you would do if you had the data sitting in front of you, say on a piece of paper, right? And then after that, translate it into those things. So do you need to create a new column at any point? If you do, then that's a mutate. Do you need to sort the data at any point? That's an arrange, right? Do you need to create a summary by group? Then that's a group by summarized thing, right? Do you need to restrict the observations in some way? Are you looking at only a subset of the data? That's a filter, and so on.